2018, number 5, part C. So it says the particle is moving along, so we think of all our particle motion stuff. The distance between the particle and the origin increases at constant rate. So they gave me a rate. Let's think about that, right? And then find the rate, okay? So here's the thing. Look, they gave you a rate. They said find a rate. So that makes this a related rates problem. You got to think about your related rate stuff. So look at your given information. This is given information. This is the function that relates the two variables. All right. So what's our given information? And what's our question? I like to focus on the question. Find the rate at which the angle changes with respect to time. So that means that d theta dt is our question. I usually like to track that. And then the distance between the particle and the origin. This is the second time that I've heard them talk about just randomly the distance between the particle and the origin. And that's a very wordy way to say r. And they remember that one with it was, what is the average distance to the origin? Distance to the origin is just r. So I'm starting now to notice that they like to disguise that way and sort of make that a little less clear than it could be otherwise. All right, so that's just r. So when they say that distance between the particle and the origin increases at a constant rate of 3 units per second, what they're telling you is dr dt, because it's a rate with respect to time. So they're telling you that dr dt equals 3. All right, and then with that, we want at theta equals pi over 3, right? When the position corresponds to theta equals pi over 3. So when theta equals pi over 3. So that's all given information. We have the function r equals 3 plus 2 cosine theta. None of these variables are time. So when we do, this is a related rates problem. When we do derivative with respect to time on both sides, like we do for that, we have to remember that it's really implicit differentiation because none of these variables are t. So when I do the derivative of r with respect to t, it's going to be dr dt. When I do the derivative of 3, it's going to be 0. When I do the derivative of 2 cosine theta, it's going to be negative 2 sine theta. But because this is an implicit differentiation, there's a chain rule d theta dt. And again, also, the fact that that's what I was looking for clues me into that it should show up somewhere in my equation in case I forgot it. All right, now the rest of it is just plug and chug. This is so much easier than part B was. So dr dt is given as 3. Equals negative 2 sine of my theta is pi over 3, sine of pi over 3. D theta dt is what I'm solving for, so I'm just going to leave it there. So 3 equals, I guess I could do this. You could just right away say d theta dt equals 3 over, let me put the negative outside, 2 sine of pi over 3. And not simplify it at all. Just, as a safety check, you could do that. But by the way, if you simplify that, it turns out to be negative square root 3. And let's see. One thing to watch out for, they do say indicate units of measure. So if I have d theta dt, what is theta measured in and what is t measured in? Well, we know that t is measured in seconds, because it says that here. And theta, it doesn't give us a unit for it, but theta is an angle between 0 and pi over 2, so we're measuring theta in radians. So the rate of change of theta is negative square root 3 radians per second. So we're probably going to need that radians per second as a unit. I'm going to just look over the question and make sure we don't need any other kind of explanation or anything. It just says find the rate and indicate units of measure. Everything else is just informational. So I think this is our solution here.